Great. Thank you for coming here to listen to us. We have a very interesting topic lined up today. Managing access at scale is a significant challenge for most of the enterprises. Straining IT resources, creating bottlenecks, and frustration for both the user and the central IT team. My name is Sachin. I'm a senior delivery consultant, part of AWS Professional Services. And with me, I have Kesara. It's my co-presenter. He's a senior software engineer from Mendix Cloud Center of Excellence team. And today we're going to talk about how Mendix revolutionized access management with a generative AI chatbot. This solution, developed collaboratively between AWS ProServe and Mendix CCOE team, has enhanced the user experience and increased the efficiency of the Mendix CCOE team. In the agenda today, we will we'll see what problems we were trying to resolve, and we'll look at Mendix use case, followed by the overview of the solution that we've created. Then we'll see the chatbot in action in the demo section, and then we'll dive deep into the chatbot architecture and see what are the components we use to implement it. And finally, some of the key takeaways. With this, I now hand it over to Kesara to talk about Mendix and their use case. Over to you.
Yeah. Thank you, Sachin. Hope I'm audible. So let me first tell you a bit about Mendix. So Mendix is a low-code application development platform founded in 2005 in Netherlands. And after we were acquired by Siemens in 2018 as a key part of their one tech company strategy. We at Mendix empower everyone from business users to professional developers to build better software faster. By providing a comprehensive, powerful platform which supports every step of the application lifecycle, from ideation, development, to deployment and operation, while providing the tools likes of collaboration, project management, and also governance. So our commitment to quality and innovation and speed is the very reason why we have been recognized as a Gartner leader. You can see us sitting in top right-hand corner since 2017 consistently. We have a diverse set of offerings under our product portfolio, and public platform being the most popular. Our public platform is hosted in 17 AWS regions and growing, and spans across more than 170 plus accounts in different environments. We use AWS Control Tower to manage our account landing zone, ensuring proper governance. But when it comes to access management, it is more distributed, with more than 50 teams managing access to their own accounts. That's where our story begins today. After Control Tower migration, all the accounts under one organization, but some of the teams were accessing using direct IAM users, which means different user credentials for each and every account for IAM users. And most of the teams are managing using a centralized IAM approach, where users logging into a central hub account, and from there they are assuming roles to target accounts. Because there were lots of accounts and roles involved, they have to more often rely upon third-party browser extensions. And last but not least, some of the teams were using direct account federation, connecting their accounts directly into our identity provider. So all these, so all these methods were implemented differently slightly by different teams, creating key challenges for the users, especially who are already juggling with different user credentials. And top of that, from central perspective, Center of Excellence team couldn't see who had what level of access to which resources, which created a lot of identity problems for us. And we are heavily relying upon security and compliance. So when it came to a security audit, it became a compliance nightmare. So we thought we need to completely change this approach, because as Amy mentioned in the keynote, we give prominence to identity access management when it comes to a foundational in security architecture. So we decided upon changing into a centralized approach, leveraging Microsoft Entra ID for authentication and AWS IAM Identity Center for access control. There were key aspects to it, one thing being principle of least privilege access, which is very important. So we thought we wanted to enable the engineering teams to manage their own access to the accounts because they are the ones who are working on a day-to-day basis, and being our environments are dynamic and we adopt a lot of AWS services when they are released and new service coming thick and fast. So we wanted to ensure principle of least privilege, as well as for us as central team, we want to ensure all the steps in the workflow was governed properly and also quality checks in place and could be auditable with better traceability. So we introduced a central Git repository, which each team managing a dedicated team file with respect to their accounts they manage. And once the user come and commit their permissions, it flows through the different designated team approvers. And once it was approved, the pipeline provisions access through Identity Center. This worked well for us because it brings the best in both worlds, where teams able to utilize the power of self-service provisioning with agility and speed. And while as central team, we could enforce the governance, having a strong governance structure with short-lived credentials, ensuring principle of least privilege. But when it comes to a transformation like this, it had its own challenges for us. As I mentioned earlier, our workflow is based on Git, which users need to have some level of understanding. When it comes to our technical teams, it was fine to work with them, but some of the teams really struggle with that. Because let's take a typical example. Imagine a business user or a colleague from our finance department needing access to AWS resource. So they first had to request access to repository, and then they have to go and clone the repository and create a new branch and commit the JSON object relevant to their permissions with the right permission sets, and then create a merge request. Once they do that, if there was any error in how they did it, they had to dig through the pipeline, find the error, and redo the entire process. And this was already a lengthy process, and it also became a frustrating user experience. So, and users didn't have a clear way to see how the request flows goes, whether they got approved or not. So the impact also felt on CCOA team, who had to handhold the teams while through the process, and also there was recurring requests coming thick and fast into our Slack channels and also team channels. So that's where we think that we need to innovate this approach and provide a better user experience for the users. That's where we brought upon a generative AI chatbot, keeping our backend, but now the users having to work with a generative AI chatbot rather than going through the complex JIT operations. And this significantly simplified the access management for us. So now it's time for us to see how it really works in our environment. Over to you, Sachin.
Thanks a lot, Kesh. So now let's look at the chatbot in action in the demo section. So what we're trying to do is mimic a typical user journey. So the user wants to provision access, or they want to access an account. So the first thing they do is go to the AWS Access Portal, as you can see over here, and they are looking to access an account called observability. As you know, it's not showing up here because the user does not have access to it. So then they go to the chatbot, start interacting with it with a simple message, and the chatbot sends a response. It introduces itself, and it asks the user to provide 3 inputs: AWS account ID, single or multiple account ID on which they want access, the name of the permission set, and the principal name or the identity information. If it is an email, if it is a user, then email address of the user, or if it is a group, then the name of the group. The user can provide the input in multiple set of messages, but they can also provide all of the input, and the chatbot will then process the request. Moving further here. Now the user is providing the input. They are providing the account ID. Some of the information is masked here for confidentiality, but you will be able to see the end-to-end chatbot interaction and the workflow. So the chatbot then acknowledges that it has received the account ID, and it is asking the user to provide the further missing information. Now the user is not sure of which permission set to use, so they are providing the use case of they want to check the billing reports and create some budget alert, and they're asking the chatbot to provide some recommendation in terms of using some of the permission set. So the chatbot goes to the backend and analyze the use case that the user has provided, and it will check the pre-created permission set that it has access to, and it will then try to provide recommendation to the user to use some of the permission set that the user can use, depending on the use case provided. So now it has provided the recommendation. It's called global billing permission set, and it has listed down the actions which are allowed as part of the global billing permission set. Now it is asking the user to confirm whether they would like to go with this recommended permission set. User can reject this recommendation, or they can provide further context on the use case, and then that will provide, the chatbot will then provide a better recommendation depending on the context, of course. So here, the user is okay with the recommended permission set, and they're then providing the group information or principal information. The chatbot goes and then validates all of the information, and it has provided the response that the identity information or the principal information provided is not valid. It does not exist. So this showcases that we're providing early feedback to the user, and if you relate to the challenges described by Kesara earlier, so earlier they had scattered feedback loops, so we are providing all the feedback and as early as possible in the similar user interface. The user can then chat with it using natural language and know more about the issues. It can also provide help to the user to resolve any errors as well. And the chatbot is also equipped with Mendix internal sources, so it can point to the right team if it does not have the answer to some of the question. But in summary, it helps the user to troubleshoot the error, and the user can also ask technical question about the errors as well. Now, but in this case, the user realized there is a typo in the identity information. They provided the right identity or principal name. Chatbot then validates it again. This time the validation is successful, and it has also checked the duplicate assignment with the provided input, and everything seems to be sorted here. Finally, it asked for a final confirmation to the user. User provided the confirmation, and then it goes in the backend and interacts with the external CI/CD system, and it has created the merge request. And you can see as part of the response, it has provided the merge request URL, and it has also listed down the approvers with whom the request is pending. We are also providing all sort of guidance to the approver in terms of the requester details and all the metadata, so it will help the approver to provide an informed or take an informed decision. Moving a bit ahead here, but in normal situation, the approver will get notification. They will take an action on the request. Moving a bit forward, and here after the request is approved, as you can see in the last message, the user gets the notification that the request is processed, and it also provides instruction on how to log into the account. User then goes back to the access portal, and now they have access to the observability account and the permissions that is assigned, which was recommended by the chatbot. And the user can then click on the permission set, and they can access the account. So that's how the end-to-end access management process works. Let's now look at the different components which makes this possible. So as you can see, the user has interacted with the user interface. So we are using a Slack application dedicated for this. The reason of choosing something like Slack is this is the internal collaboration tool used within Mendix. So we wanted to provide a seamless user experience. And there's a dedicated application created for this, and it is added to Mendix workspace. So anyone who wants to access the chatbot, they need to be authenticated by Mendix corporate identity. And they can directly then interact with the application, or they can invite the Slack app to some of the private channels that they might have for their team. For each message sent, Slack application signs the HTTP post request, and it invokes an Amazon API gateway, which then triggers an integration lambda. The responsibility of the integration lambda is to validate whether the input is really coming from Slack. And for that, it uses the same signature which is used by Slack application while invoking the API gateway. And once it validates, once the validation is successful, it then invokes Bedrock Agent by wrapping the input provided by the user in an API call. We are using Amazon Bedrock Agent to orchestrate between different components and fetch the response from the input provided by the user. But before it goes and constitute a response, we are making it pass through a filtering stage where we're using Amazon Bedrock Guardrail. We are filtering out undesirable or harmful content. It also provides safeguards against prompt injection attack. And to enhance the response, we're using a RAG-based approach, using knowledge base, and we're using Amazon Aurora serverless as a vector database. And different Mendix internal sources are connected. And this is where the recommendation engine, as you mentioned, as you've seen in the previous section, this is how the recommendation engine is providing better recommendation in terms of choosing a permission set. It also has a different agent actions configured in the form of Lambda function, and this is where it is interacting with internal APIs, internal AWS APIs like organization to validate the account, whether it is part of organization, whether the account is active, and the other set of input like principal information and permission set. It is calling the Identity Center API to check whether all of the input is valid. And it also, as part of the agent action, interacts with the CI/CD system and creates all of the merge requests adhering to the branching guidelines provided by the CCOE team. And once all of these is done, we're also storing some of the metadata in DynamoDB table. The metadata includes the requester details, the response from the CI/CD system. So we're using these information to send notification to the user, and also can be used for audit purpose. So the integration lambda, as I mentioned, calls the Amazon Bedrock Agent API. It's a synchronous API call, so the lambda waits for response from the Bedrock Agent. Once Bedrock Agent has the response, then the lambda fetches it, parses it, and sends it back to the user via API call, and that's how the user gets a response. So this process and workflow is done for all of the messages sent by the user. We achieved some great result with this: 90% reduction in time taken to provision access, 95% increase in SSO adoption within Mendix. But what I want to emphasize here is some of the key takeaways that we learned while implementing this solution. We all know that generative AI system can generate highly realistic content, text, images, and videos, but it can also generate outputs which seems plausible but are verifiably inaccurate. For that, incorporating human judgment becomes crucial, and if you're dealing with sensitive topic like access management, that really becomes critical. So we deliberately wanted to put the decision making to humans in the form of approvers. So it has to go through an approver, and then approver will get all the feedback from the generative AI system, and they can then take an informed decision, as I mentioned earlier. The other thing which we contemplated a little bit is centralized versus distributed approval model. As Kesara mentioned, they wanted to promote self-service. So distributed approval model is something which was sort of a straightforward decision in the case of Mendix. And we also wanted to separate the identity and access management. Identity management is being taken care of by the central identity team, and access management is being then taken care of by the application owner, account owners, so that follows a distributed approval model. But if the organization has the need to configure centralized approval model, that can be configured as well with a central security team or CCOE team taking decision in that case. We also wanted to use the sheer scaling in which generative AI system function. As you have seen in the demo, we're supporting account assignment in bulk, and that's what we observed. In multiple application team uses a lot of different accounts spread across different environments, so they want the access to be configured in bulk. So the chatbot supports that, and the use case then can then be expanded into supporting the organization unit, because a lot of enterprises use this organization and they have the accounts as part of the OU. So given the input as the OU ID, the chatbot can then go and deconstruct and get the list of accounts, and then it can provision access to that account. And not just access management, the CCO team is evaluating multiple other options as well, which will help them release some of the bandwidth, and so they can focus on critical activities which brings business value to Mendix. That's about it from our side. Thank you for listening to us. Please complete the session survey in the mobile application, and if you have any question, please feel free to reach out. Thanks a lot.